So when we measure angles, typically you had been measuring in degrees. And what we know about degrees is that there are 360 of them in a circle. So what you can do is imagine a circle over top of, like a coordinate plane. So if 360 degrees is in a full circle, remember the initial side is here. And so if the initial side is here, 0 degrees would be here because we haven't moved at all. So that's 0 degrees. 360 degrees would be a full loop around the circle. From the initial side here would be 90 degrees. From the initial side all the way over here in a straight line is 180 degrees. And from the initial side down here would be 270 degrees. So that's how we would label a circle, the basics in degrees. Radian, the definition of a radian, 1 radian is the measure of an angle theta that intercepts an arc S equal to the radius R. So you can kind of draw a picture of what 1 radian is. So imagine we have a circle here. This distance right here is R, the radius. What this definition says is that 1 radian is, imagine taking that radius length and wrapping it around the circle that has an arc length S equal to the radius. That angle here, from the initial side to there, theta is 1 radian. So the distance from the initial side out to here, theta is equal to 1 radian. So what we know is 1 radian, 2 radian, there's 3 and a little bit radians in a straight line. So what we talked about was the fact that there are pi radians in a straight line and 2 pi radian in a full circle. So 360 degrees in a circle, there are 2 pi radian in a circle. Pi radian, half of that would be pi over 2 radian. And down here would be 3 pi over 2 radian. So what we want to talk about is converting, using these ideas here to convert between degrees and radians. So what you want to use is the idea that 360 degrees, which is a full circle, is equivalent to 2 pi radian. You can also use this over here, knowing that 180 degrees, a straight line, is pi radian. What we're going to do, both of these are the same thing. Hopefully you can see that this equation is really the same as that one, just dividing by 2 to get here. So what you can do, I like the scaled down version. What we do is use this as a conversion factor. So for example, if we wanted to take something like 690 degrees, what we're going to do is multiply it by our conversion factor. And the conversion factor we're going to write as a fraction. So think about what units you want to get rid of. I have degrees and I want to get rid of degrees. So that means I want the unit of degrees on the bottom and the unit of radian on the top. So looking at this conversion factor, my 180 will go on the bottom and pi on the top. Now, when you're doing this, we're going to convert into radian. And so usually pi is going to be in the answer. So all you're left to do is take 690 times 1 over 180, or 690 divided by 180, just taking that fraction and simplifying it. That comes out to 23 over 6 pi radian. So 11 pi over 3. Again, we're going to multiply it by our conversion factor. This time I have pi, so I'm in radian. So I want to put radian on the bottom and degrees on the top. So I'm going to multiply. My conversion factor now will be 180 over pi. The pi's cancel out, and all you're left doing is 11 times 180 divided by 3. And that should come out to be 660, and the unit is degrees. Here are some for you to try.